Good morning everybody. Today we'll be seeing what is a simple LR parser, also known as SLR parser. We directly begin with the designing. The steps to design the simple LR parser. Step number 1, add an augmented production in the given grammar. Step number 2, create canonical collection of LR0 items. Third is draw the go-to graph, and fourth one is to construct an SLR1 parsing table. Let's check. This is the example for which we are supposed to design the SLR parser. Now here we start writing the augmented grammar. Now augmented grammar is any extra grammar which is of the form S dash, which is tends to dot E, because E was our first production. This was our first production. As a result, we are going to just augment one extra grammar which is going to tend to the first grammar, the starting grammar. And the other grammars, I have written them as R1, R2, R3, R4, R5, indicating these are the reduce operations. We will be using these notations wherever required. Next thing is we need to calculate the follow of the given variables. Now the follow of the variables E, T and F have been calculated accordingly. This is the follow of E, this is the follow of T and this is the follow of F. This will be required when we are going to make entries into the SLR table. This is the go-to graph which we have designed. Now if we check, we have started designing it with the help of the augmented grammar. I have written S dash tends to dot E. Now the rule for designing go-to graph is if there is a dot before the transition, before any variable, we need to include all the transitions of that variable too. As a result, I have also written E tends to dot E plus T and E tends to dot T. Now, since I have dot T, hence all the productions of T also need to be included. As a result, I have written T tends to dot T into F, T tends to dot F, and since there is dot F, so we need to include the transitions of F. Hence, we have written F tends to ID. Now, I have 4 ways out. It's E on T, on F, and on D, ID. What do this mean? If there is a transition on E, what will be the state which we are reaching? Hence, if there is a transition on T, what will be the state we are reaching, and hence and so forth. Now, if you see, transition on E means if I move this dot from the left hand side to the right hand side of the variable, what will be the final solution? As a result, on E, if I move this dot from the left hand side to the right hand side, the new state which I get is S dash tends to E dash or E dot, and E tends to E dot plus T. So I name the state to be my I1. None of the variables more will be hampered. Now if there is a transition T on this given variable, what will be the status? We'll have E tends to T dot and T tends to T dot into F. So this is I2. Accordingly, we have taken on F and on ID. So we have renamed those states as I1, I2, I3 and I4. Next, from this state, if there is a transition on plus, we are going to have E tends to E plus dot T. If we are having dot T, hence all the productions of T need to be included. Hence we have written T tends to dot T into F and T tends to dot F. Accordingly, if there is dot F, we are going to include the production of F2. Hence we are going to say F tends to dot ID. Accordingly, we have created this entire graph. So now this graph has I0 to I8 steps. That is total 9 steps, 9 stages. And the next step is how we are going to design the SLR parser table. Now for this we require the follow which we had calculated earlier. Now if we see how have we made the entries over here. S represents shift moves, R represent reduce moves. Now if you can recollect, we had written here the reduce moves accordingly. Now just have a look here. From I0 on ID, are we having any shift operation? Yes. From I0, if I go on E, if I go on T, and if I go on F, there are no shift operations because shift operations will always include terminals. As a result, if I have ID, I have finished this operation because this operation says F tends to ID dot, finishing this entire operations. Hence, I am saying S4, that is reduce using state 4. So, we are writing here S4. Next, let's go to the go-to graph. Now, this go-to graph, please make a note. We will be having in the action table all the terminals, and in the go-to graph, we are going to have all the variables. In the go-to graph, if we see I0 on E, I0 on E, we are actually completing one entire stage, that is S dash tends to E dot. As a result, we are not going to say this is shift operation because this is related to variables. Hence, we are putting this under go to graph and we are just going to mention the name number of the stage. So, we are putting here as I1, only one, sorry. On T, if you check on T, we are again completing one stage, that is E tends to T dot. As a result, we are only going to mention the state number, that is 2, below the go to graph. Same way for F, we are going to mention only 3, which tends to I3. This completes all the transitions of I0. Next, we move on to I1. If we check on I1, yeah. So on I1, we are having input on one terminal. So I am going to first check which transition is complete over here. We are having transition E, S tends to E dot complete. As a result, we are going to look for the follow of E over here. Now, referring to the follow of E over here, follow of E is plus and dollar. Now, on plus, we have a shift move. We are moving to 5. As a result, for plus, we are going to write S5, indicating we are shifting on move 5. Whereas I1 on dollar is accept, because I1 on dollar will be completion of this first augmented grammar, and if we are completing the starting variable itself, it indicates that the grammar has been parsed successfully. As a result, we are going to say it has been accepted. Now next, let us move to I2. Now from I2, we have a transition on multiplication over here. But if you check I2, we have completed this transition E tends to T dot. As a result, we are going to look for the follow of T. So the follow of T is into, plus and dollar. Now into, we already have a move to I6. So below into, you are going to just write down S6, indicating shift move to 6. But what have I written below plus and dollar? If you check plus and dollar, we are completing this entire stage. So as a result, if we are completing this, this is now going to become a reduce operation. As a result of reduce operation, we need to find out which is the operation related to this. Yes, if we are saying E tends to T, this is the reduce operation which we are using. As a result, I am going to write down R2 and R2 below this, because this is the second reduce operation which we are having. Here if you see, there is no transition on any of the variables. As a result, we are not putting anything under the go to graph, same as I1. Moving to I3, if we see in I3, we are just having one transition, T tends to F dot, which is a complete transition. As a result, we are going to look only for the follow of F. So the follow of F is multiplication plus and dollar. Out of these three, there is no transition on any of these variables from here. As a result, we are just going to specify this reduce move below all the three terminals. So which is this reduce move? This is the one R4. So we are just going to put R4 below all the three variables. Similarly for I4, if we see for I4, we are completing this transition. F tends to ID dot, and there is no move whatsoever anywhere. As a result, we are going to mention F tends to ID dot indicates what is the follow of F. So follow of F is multiplication plus and dollar. So we are going to just put R5 below it. Why we are putting R5 is because this is the transition R5. For I5 and I6, if we refer, for I5, we are having a transition on T to I7. As a result, we are going to put 7 under T. This is because this is a move on the variable. Same way, a move on F is having 3. So from I7, yeah. Accordingly, if you check, we have a move on F on 3, sorry, from I5. As a result, we are going to put it F over there. So we have made an entry accordingly 3. And I5 to ID, we are having I5 to ID. We are having a transition on I4. So for that reason, we are going to write S4. Accordingly, we have completed this entire parsing table. Now, if there is no conflicting moves over here, we say that this grammar is parsed by an SLRParser table. Now, if there is a conflicting move means in the same move, if we are having, for example, in I2 to plus, we are having reduce as well as shift. If we are getting conflicting move for a similar same terminal, then we say that we cannot design SLRParser for this given grammar. In this case, we can successfully design SLRParser because we are not having any kind of conflicting moves here. Thank you.